Everyone, I'm actually inspired to create this video because my last video created so much traffic. It hanged the YouTube servers. Let me count. Total 150 count. To very close to T series. Okay, jokes apart. Let's jump back to this problem. 60-second problem, unique paths. What do we need in this problem? Again, this is a 2D grid problem. Most of the 2D grid problem follow the same patterns. If you go back to my last video, which was 64th minimum path sum Leetcode problem, we are following the same pattern. It's just we are going to tweak the formula a little bit to solve this one. Okay, let's first understand the question in detail. Okay, we will jump back to question example 1 later. Let's first take the example 2 because I can see that is little smaller and easy to understand. Okay, in this problem what we have to do, we have given the starting point, we have given the end point. We have to find how many unique paths are there to reach to the finish line. Okay, how do we know that? Okay, here for example 2, forget about this thing. Let me drag that into right hand side because that does not matter for now. That's for our algorithm. On the left hand side, I'm taking the example 2. Okay, what do we have? M represent the rows, N represent the number of columns. So we have 3 rows, 1 2 3. We have 2 columns, 1 2. How many unique paths are there to reach to the destination? All right, first is this, second is this, and third is the zigzag. You see, there are the only 3 paths that there are only 3 unique paths to reach to the destination. That's example 2, and you can see the output is 2. Okay, now let's jump back to example 1 and see how many unique paths are there. Okay, if I start from here, follow my cursor on the screen. This is one path, this is second path, this is third path. Now I'm not gonna count all the paths, but that way you have 28 different paths. Now how do you solve dynamic programming problems? You divide the entire problem into sub problem, you find the solution for the sub problem, and then use the same solution to solve the entire problem. Now, given that, let me get this on the left hand side. Oops, come on, there you go. Okay, let's say we only have one cell. The start and end is the same. How many unique paths did you take to reach to that cell? One, right? You start and you end. You started and ended there. Let's say we have 2 cells in a one row. How many paths? This is your source, this is your destination. Follow my screen. This is your source, this is your destination. How many paths do you need to reach from the source to destination? Only one path, right? Just walk. For one single row, how many paths are you going to need? Just one path. You are just going to walk on the right hand side. Same way for column. How many paths did you take to reach to the bottom? One path, just one step below. Same way, if you add one more cell to the column, how many paths did you take? Just one, right? You are just climbing down. Now the interesting condition comes. Okay, what happens if your cell is coming from 2 different paths? Here there are actually 2 paths that are coming in, one from the top, one from the left. So in order to reach to this cell, we are going to sum these 2 paths, right? Bear with me for a minute. Okay, now visualize this. In order to reach this cell, we are going to have this one unique path and this one unique path, so 2 unique paths. So we are just adding those 2 numbers, and that's the result. Now let's put that into this first example. Okay, you begin here. Okay, all of your cell values, all of your first row values are 1, as we saw in the previous exam, as we saw before. All of your columns are 1. Sorry, all of your first column values are 1. Here is the summation of previous row and previous column, so 2. Again, follow the same formula. 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6, 6 plus 1 7. Same, 2 plus 1 3, 3 plus 1 6. Oh my god, 2 plus 1 3, 3 plus 3 6, 6 plus 10. What happening with me now? 6 plus 4 10, 10 plus 5 15, 15 plus 6 21, and 21 plus 7 28. And check, that is the result here, 28. That simple it is. dynamic programming is not as hard as you think it is. Okay, what do we need? We need a dp table, right? All right, let's begin with dp table. Let me bring my this thing. So we are directly jumping into code now, because I guess you understood the approach. There's only one condition, right? So we need dp table. So let's create one. dp is equal to new integer. I'm using jagged array. Jagged array is array of arrays in C sharp. Okay, so in when you initialize the array, you have to define how many rows you're gonna have. M represents a row, so I initialize with the rows. Now we're going to traverse or iterate through the 2D arrays. So row is equal to 0. Row is row is less than m, and row plus plus. Then now we are going to iterate through the columns. So integer column is equal to 0, column is less than n, because that's what's column represent in this problem. And okay, now one additional thing I have to do, which you might not have to do, since this is an array of array, I have to define length of each row as well. How do I define that? I access that row first. So that's how you access the row in jagged array, and you initialize with new integer array with the size of n. Okay, what do we need? We are filling first row and first column with zeros, right? So if my row is 0 or my column is 0, what I am doing, I am filling my dp tables each cell, I mean first row and first column cell, with 1. Else, if it is not the case, then what I'm doing for all the other cells, I'm doing summation of previous cells. So for all the other cells, dp row column is equal to previous row, that's been row minus 1, and same column, plus dp of previous same row and previous column, so column minus 1 here. Now once you have that, we are storing the result in the last cell. So let's just return that dp of m minus 1, m is the row and column is n, so n minus 1, and that should do it, I believe. Let's run this. Okay, test cases have been passed. Right, let's submit the solution. Let me get myself on the right hand side. Waiting. Alright, we are passed. 26 milliseconds, not bad. Let me submit it again and see if that changes. 14 milliseconds, see? So 14 milliseconds. Alright, whatever it is. Let's understand time and space complexity. Okay, just look at it. You will get the answer. 2 for loops, 1 for row, 1 for column. So your time is nothing but, let me add it here, big of m into n. M represents your row and n represents your column, right? Because you're doing these operations for say every cell, right? So m into n. Space, what do you think what the space would look like? Big of m into n, because we created the dp table which will represent m into n. We created 27 cells, if you remember in that example. So we are creating number of cells, that is number of cells to fit in that array. So that's why the space complexity and time complexity in this example is same. Well, that's it, folks. Thank you so much for joining. For next section, what I will do, I will create the advanced version of this problem, which is, what is this, unique path, right? Unique path 2, which would be 63rd problem. What I want you to do, how about before we jump into that problem, you create the dp table on yourself, by yourself. If you are able to create a dp table by yourself, then that's the first step, and I'll again come back and explain you how that works. If you're not able to, don't worry about it, but try it out and see if you're able to at least think out loud how to generate a dp table. Wrong values doesn't matter, we'll correct it later. Alright, thank you so much for joining. I'll see you in next one. Ciao.